Well, let's start with the insertion sort thing. Honestly, I haven't revised it. I will. It will just be an intuition-based tutorial. Let's start. The insertion sort. So, the basic idea. We already know we are supposed to sort the array. So the basic idea of this mechanism, you can take example of some cards. Let's say you have these three cards sorted, and then you insert a fourth card in these sorted cards and rearrange these four cards in a way that they are sorted, and that's why the name insertion sort. Okay, so now let's see the basic thing behind this. Okay, so for the algorithm perspective, basically the thing is you sort the array partially, like when you reach suppose you have done the sorting, suppose the fourth element of this array has come in your process, then till the fourth element your array is sorted with these four elements only. Fine. Okay, so then let's get into the mechanism. The basic thing is let's consider this example as 4, 7, right. So for the first element, this is already sorted, right? Then we insert the second element in the first element. Now this will be like 1, 4, right? Again then we insert the third element. What happens is 1, 4, 7, 11, 23. And even after inserting the next three, we get the sorted. So you got the basic idea of sorting this. Okay. So then, basically it is used to get partial sorted array sometimes. Okay, so let's try to write algorithm for this. Okay, so the rounds, how many rounds will take place? Rounds will be, of course, n minus 1, because we will not sort the first element, we will start sorting from the second element till the last element. We will start basically inserting from the second element till the last element. Fine. Okay, so look, in our first case, what we did was, when you insert 1, you compare 1 with this element, and if 1 is less than this, you forward this element and make the positions value as 1. Okay, so the thing will be to, let's try writing it in the code itself. So how many rounds? N minus 1. So what I write here is, for I equals to 1, to I is less than n, I plus plus, what we'll do is, as the comparison will start from the first element, like the second element, but the element having the index 1. So I equals 1, what I will do is, I write again a for loop for the comparison thing. I will write for int j equals I minus 1 to suppose this is the element, so we are concerned only about this array and we'll compare with the elements of these array. Okay, and here you go, j is greater than equal to 0 till the first element we will compare, and j minus minus obviously. Then what you will do is, now if array of j has the value greater than array at I, what you will do is basically you will add the array of, you will update the value of the next element with this element, and then for that element you will have the value of, here are I again. Okay, is there any problem in this? I guess there is a problem. Error of j plus 1. So let us say I have this element and I have compared this with this. So if this is greater, so then the next index has the value of this, and this index has the value this. And if I go to here, again this will have the value of this, and so I guess it's correct. This is the thing, and find it. Okay, so for the time complexity thing, space complexity is obviously big of 1 only, as we haven't created any extra space. For the time complexity thing, generally we will, so how many comparisons are we doing? For the first array, well, so for the time complexity thing, time complexity will basically be equal to the number of comparisons. So for the first round, what we did was only one comparison. For the second round, we did two, and till the last element, we will be doing n minus 1 comparisons. So it will be big of n square, right? And so then this is the time complexity thing. Now let us think about the best case time complexity, right? When your array is already sorted. Okay, so look, what we'll do in this code is, we will have to use the break statement, right? So like, if the array is sorted, this is 7, this is 4, this is like this. So if 7 is already greater than 4, there is no need to compare beyond. Okay, so by this the base case time complexity will be big of n. So let's try to update it in our code. Okay, well, so let's try to update in our code. Again the code will be like the previous only, int I equals 1, I will be less than n, I plus. For g again you will select j equals I minus 1, j should be greater than equal to 0, you get j minus minus. Okay, then what we supposedly did was to, again there is a okay, we'll just write an else statement here. Then what if error of J is greater than equal to, no, greater than equal to error of I, then you are gonna update it, and you are gonna update it like this. Error of J you will replace with error of I, then you are gonna do this. Again, this is wrong, very wrong. Just wait for some time. Look, here error of J plus 1 will have the value of err of I, and error of basically this will have the value of error of J. Okay, so this is the thing, like we, and if this doesn't happen at any stage, we will break the loop. Okay. That's all. That's what I think without revising about insertion sort. This may be wrong. Let's see.